So here I have a few problems for you. It's from a pop quiz, and it's typical of questions you might have for the mcat. So this is only kinematics, but they are very simple problems, right? So you might have a few of them. It's conceptual questions. So the first one you might pause the video, but it's a very simple one. And just for you to understand, they want to make sure that you understand what acceleration is. So this is east and this is west. You always want to draw the situation. Then you have a truck here, and the truck is moving to the east, right? And it's gonna slow down. So it's slowing down and at a constant rate, and it's gonna stop eventually. So it's gonna stop, right? So the acceleration will be in this direction. So you can think of acceleration is proportional to the net force, right? And the net force, it has to be to the left. It has to be westward because it's the static friction here. It comes from the brake. So of course it's going to be in this direction to change the magnitude of the velocity. So it has to be west, right? Or you can say the acceleration is v2 minus v1 over t. So the acceleration will have the same direction as v2 minus v1. So it's like adding vectors, right? So if you have v1 is in this direction, then you have v2 here, which is smaller. So v2 minus v1, so it's v2 here, and then minus v1 will be in the opposite direction. So that will be minus v1. So that vector here will be v2 minus v1. Okay, so it will be to the left. So let's look at the second one. Which one is not a vector quantity? So displacement is a vector. Okay, so when you have a displacement, it means you start from a point A, you go to point B, doesn't matter how you make it. Here, the displacement is a vector, so you have to connect starting point to the last point. That will be your vector AB. The acceleration is a vector, okay, because it's a change in velocity over time, and velocity is a vector, average velocity is a vector. So the only one that is not a vector is the speed, and this is called a scalar. Okay. Next one. Okay, so I have seen problem like that, displacement. Just to understand that displacement is a vector. So you go, this is east, and this is west. 3 inches east and 4 inches, 5 inches west. 1, 2, 3, 4, 5. So you go from A to B. So the displacement will be this here. So it will be 2 inches at west. Here. Okay, so this one is easy also. You can think of that if you are swimming in a pool and there is a counter current, right? So relative to the ground, it seems that you are not moving. You are only moving relative to the water, and the water is moving in the opposite direction relative to the ground. So relative to the ground, of course, you're not going anywhere. Right? Makes sense. So algebraically, you can say your speed relative to the ground is the speed of you relative to the pool plus the velocity of the pool relative to the ground. You can do it this way. Let's say this is positive here. So you have a velocity, let's say 3. The water has a velocity -3. Okay, so u relative to the pool is 3. The pool relative to the ground, so this is the ground here, it's going to be -3, so it's going to be 0. So here you go from here to there, and you see you cannot go from here to there. It's a typical question because there is no motor attached to the skateboard. So obviously you have to go from this point to that point here. So you are slowing down. Okay, so you are slowing down. So your velocity is to the left. Okay, so the velocity is negative and the acceleration will be positive. So right is positive, left is negative. So the velocity is negative and acceleration is positive. So the only answer is velocity is negative. So it's a little bit tricky here. So this one is easy, just very basic question here. So you have the acceleration. So it means it's going faster by 50 meter per second, right? So it means every second is going 50 meter per second faster. And if you do that for 1 minute, so 1 minute is 60 seconds. So the velocity, the final will be 50 times 60, which is meter per second. Okay, so typical question also here for the next question. So it's a typical question where you have to be careful because displacement, if you go from A to B, displacement connect the dots here. So if you go from here and you go all around and you come back here, the same place, the displacement is going to be 0. Okay, it's a vector, so it's going to be 0. So the average velocity, by definition, is the displacement, or you can, it doesn't have to be along the x, it could be AB in 3 dimensions. The displacement is 0. So the displacement is 0. If they ask you, and the average velocity is 0, if they ask you for the average speed, it's not going to be 0. Okay, so the average speed is the total displacement over time, and the total displacement will be displacement g, and the displacement will be 2 pi r if you go round trip. So the average speed will be 2 pi r over t. The average velocity will be 0. Okay, so the relative speed here kind of makes sense that if one of them is not moving, the relative speed will be 3. For example, if this one is going at 3 and this one is not moving, if they are both moving toward each other, that means it will take less time for them to meet. So everything happens like they have a larger speed. So the relative speed should be 5. So 5 is the answer. Now, if they move in the same direction, it's gonna be taking less time for the blue car to catch up with the red car, for example, right? So if they go in the same direction, then you subtract. So the relative speed is 5 in that case. Okay. Let's see if we have another one. So let's see this one. So what does it mean? Acceleration of 2 meters per second. It means that the speed of the particle increases by 2 meters per second each second. So this one is easy. What about that one? This one. What is the acceleration? So you see it's going to slow down. It's slowing down mostly because the parachute is open, so the drag, the air resistance is to the left. So if the air resistance here, the force here is to the left, the acceleration is also to the left. So it's going to be negative. So the acceleration is negative. So how much is the acceleration? It will be the change in velocity over the change in time. So change in velocity will be 15 minus 25 over 9 to 12, so 3. So it's going to be 10 divided by 3, so it's going to be 3.3. So acceleration is minus 3.3 meter per second. Okay. Last for so acceleration of the ball. So the acceleration will be the final minus initial over the time. So final will be minus 10 over 0.1. So this is tricky because you have to remember that velocity is a vector, so it has a direction. So this is a positive direction to the right, this is a negative direction to the left. So that will be minus 20 over 0.1. So the acceleration will be minus 200 meter per second. Okay, so also typical question. Okay, so what about this one? So this one is the displacement. So you first of all, it's good to draw the number line, but it's just knowing the equation by heart. Not. Maybe you don't have to know it by heart. Okay, so of course you can do the equation, which is okay. So you go on the number line here. You start at x equals 0. You have your stopwatch here, which is 0. And the initial velocity here is 1 meter per second. He's going to accelerate. Okay, there is a force pushing him forward. And the acceleration is 2 meter per second. And he's going to run for 10 seconds. So you can use the equation delta x equals initial speed plus 1/2 at squared. So displacement will be initial speed is 1 times 10 plus 1/2. Acceleration is 2 and then 10 square. So that will be 110. Or, okay, if you don't want to memorize, you can remember that if you have velocity versus time, the displacement is the area under f of x, right? Or the velocity. as a function of time. So it's the area under the velocity as a function of time. Okay, so velocity starts with 1 and it's going to increase at a rate of 2. So it's going to be a straight line. It's going to increase. So after 10 seconds here, that's t equals 0. T equals 0, velocity is 1. Then after 10 seconds here, 10 seconds is here. So the velocity will be, you have an increase of, so that will be 21. You have an increase here of 20, right? Because it's 2. 2 times 10 is 20. Okay, so the increase in velocity equals 20. So if you don't want to memorize that, you can think of the displacement will be this area here. Okay, so the area will be that area here, which is a rectangle, which is 10 times 1, plus you have a triangle, so it's 1/2 the base times the height here, which is 20 square. So 10 plus 1/2, 10 times, which is 5. One times the base. The base, 1/2 the base times the height. So there is no square, which is 110. So that way you don't have to memorize that. And there is so much you can memorize, of course. So in that case, the velocity here is to the right, the acceleration is to the left. So you can pause the video, but the car is moving at right. And this acceleration here is going to change the speed. Okay, it's going to make the speed smaller. So it's going to slow down. Okay, so here something to remember. If you look always at the acceleration, no acceleration, no velocity, position stays the same. No acceleration, constant velocity, position, the position on the number line relative to x equals 0 is going to increase at a constant rate, right? But it has a constant velocity, and the velocity will be the slope of position versus time. If you have a constant acceleration, velocity is going to increase at a constant rate. The slope is the acceleration, and the position will be a parabola. Because the position for every second here, you're going to make further. Okay, the distance travel will increase. The slope here, it's going to be the velocity. So velocity is going to increase, but at a constant rate because the acceleration is constant. Okay, so here you have position versus time. It's a straight line. It's a straight line. Okay, so the slope is the velocity, and you see the slope stays the same. So velocity is constant. So this is the answer. So this is called graphing analysis. So here you see that you have a parabola. The definition of a parabola is that the slope is going to increase. It's increasing at a constant rate. So the slope is the velocity. And the velocity is not constant. It's going to increase, but at a constant rate, which means the speed is increasing, the acceleration is constant. Okay, because you get that parabola only for a constant acceleration for a constant force. So this one is easy, but you have to go fast, which is for an object at rest. So not changing position, velocity is 0. So here you have velocity, but it's constant here, it's not 0. That will be the position, and here the position stays the same. So that means it's not moving. So the answer is A. Okay, so this one, I don't know, have two questions in the same, but I think the question is this one. Which graph describes an object moving at left? So if an object is moving at left, that means the velocity is negative. If the velocity is negative, that means the slope of position versus time is also negative. Okay. So in that case, you see it's a constant velocity, but the slope is negative, the velocity is negative, so it means it's moving at left. So the answer is C. So an object is moving with a constant non-zero velocity. The velocity versus time graph of the object is, so if you do velocity versus time, but it's constant. So if you have a constant velocity, but non-zero. So this is 0, this is constant velocity. You see that the graph has to be horizontal. It's a horizontal straight line. So here is the two car. The blue car is moving at a constant speed. At t equals 0, the speed was 10. Okay, and it's 0, 10. Okay, and it's not 10. That will be the position, sorry. So this is a position versus time. The blue car is moving at a constant velocity. Okay, and the velocity will be the slope here. Say slope, position is meter, time is second, so meter per second. And the red car is at t equals 0, it has no velocity, and it's going to accelerate, and at some point it's going to pass the blue car. So they're going to meet at that point. So the question is, what is that point here? So that point will happen at 100 meters here and about 4.5 seconds. So now they want you to find the equation here. So of the blue car. So you can pause the video and look for the position of the blue car, the equation. It's called the equation of motion of the blue car. So you see that the y-intercept, so an equation is y equals mx plus b. But in that case, we want the position as a function of time. So x equals mt plus b. So this is the y-intercept, and you see the y-intercept in that case will be 10. And what is the slope? So m is the slope, right? So m will be delta x over delta t, which is also the velocity. So you start from here, and let's say you go here. Okay, so you go between 10 and 50. So that's going to be 50 minus 10 over time elapsed is 2, which is 40 over 2, which is 20. So that will be 20t plus 10. So that line here is 20t plus 10. So that will be like that here is a parabola, right? So it will be something, the initial velocity is 0, so it will be 1/2 at squared. But this is proportional to time t. This is proportional to the time square. A blue car you have the position. What is the equation? So the equation for the blue car, it depends on t square, right? So it's gonna be, it has the blue car. Oh no, the blue car we just did it. So it's gonna be 20t plus 10. What is true here for the red car? The red car, you see, the red car here is accelerating from rest. So the answer is the red car is accelerating from rest. Okay, let's do the last one. So the last one, is free fall, and it's easy. In free fall, so a ball is tossed up. Free fall, it means there is no air resistance. It means acceleration is always -10. So already we know it's either this or that. And at the top of the trajectory, it stops. So the velocity is 0 and the acceleration is -10. Okay? So this one, you just apply one of the kinematics equation, right? So it's going to be delta y equals initial velocity plus 1/2 at squared. Okay, you start from here, initial velocity is 0, and the velocity is going to increase at a constant rate. So this goes away, so delta y can take down to be negative. It's going to be initial velocity is 0, so this is 0. So it's going to be 1/2. Acceleration is about -10. Oh, so that will be delta y, but that's not what they are asking. Okay, so 9 squared. Okay, so that will be the height. But what they want is the final velocity. So the final velocity is -90 meter per second. So magnitude is 90. Okay, because the acceleration is -10 meter per second. So it's going to increase the speed by 10 every second. So after 9 seconds, it's going to be 90. So final velocity equals initial plus acceleration times t. So this is 0, acceleration is -10, and time is 9. Okay, so here they help you. You do not have the time, but you have the displacement, and they want you to find the final velocity. So this equation, the kinematics equation, is very convenient here, right? So it's final speed equals initial speed square plus tau 2 times acceleration and the displacement. And you are going down. So you go from here to there. So Apple is falling here, it's gonna speed up. So the final speed equals 2 times -10 and -5, which is 100. So it's going to be the square root, so it's going to be 10. Okay. So how long does it take to reach the maximum height? So maximum height, so this is tossing something up height. So at the beginning, the velocity is 20. After 1 second, it's gonna be 10. Another second, it's gonna be 0. Then it's coming back, minus 10, minus 20. The magnitude is the same. So how long does it take? So after 1 second, it's going to be 10. Another second is going to be 0. So the answer is 2. Now you can use the equation. Acceleration is minus 10. V final equals initial plus acceleration times time. Final is 0. That's going to be 20 minus 10 times t. So t equals 2 seconds. Okay, so you can pause the video. So the time it takes to reach the ground is 10 seconds, and they want to know the height. So again, you should pause the video. And you can use delta y equals initial plus 1/2 at square. So it's something falling here. So initial velocity is 0 and it's going to go down. It's going to speed up. And it takes 10 seconds. Initial velocity is 0. And the time is 10 seconds. So delta y equals 1/2 minus 10. And then here is 10 square. So delta y will be minus, that will be 500 meters. So this is from here to there, 500. So the height is 500. Okay, I think that's it. These are very easy questions. Okay.